Hello.
Hello, Professor.
Today this week will be our final week. Next the final exam it will be on the Monday, 16th. So I've not decided where it will be. I'm thinking of putting it in Canvas so that you can solve it in Canvas and then upload your work later on. So I will let you know by Wednesday. But today and tomorrow and Wednesday we'll finish everything we have. And hopefully by Saturday, I should be done with my grading of the ones that needed to be graded. Well, let's say Sunday, I should be done with my grading Sunday night. And then wait for Monday for your final exam.
Professor, you're trying to kill us.
I'm not doing nothing. What do I do?
It's a lot, like with the project and then the final exam and
it's one.
Then you postpone work this week. It's
I
a
know.
lot.
I know it's 8-week class. So what can I do? It's only 8 weeks. So I'm trying to see. I try to space it out so that you don't become too overworked. If you notice, I only give one homework in a week, then maybe one test. I don't put multiple homeworks at the same time so that you don't get swamped with work. Yeah. All right, let's see.
So I have a question. Hello?
I'm here.
Yeah, the project, are we supposed to do everything in Excel?
Yes. What I mean by that is that you can do it in Excel, you can do it however you want to do it, but it has to be typed. It should not be handwritten. So whether you do it in Excel or you're using a different software, so long as after each work you paste it in the space where it is supposed to be, and it is not handwritten, you should be fine.
Yeah? Like yes, but like the Excel, it's always to go straight to Excel. So it's the command that you can use to know if we used the format for the main media mode and so on. So
you can upload both of them, both the Excel file and the project file as well.
I don't understand the project
like
file.
When you want to upload this, you do your question like I'll give you an example like the histogram there. There's a section for histogram.
Yes.
So that histogram should not be done with hand.
I know it's Excel.
So you do it Excel and copy it and paste it on the space where it should be in the project.
I understand that, but like, what about the data and stuff like that? You got to copy paste that into the Word documents that you provided us. So we can't just submit the Excel itself. We have to copy paste it into the.
Yeah, and also make a comment because there are sometimes some of them you have to like the section that deal with confidence interval.
Right. What if you can't copy and paste it?
Of course, you can copy and paste. And it's very easy.
Okay.
Yeah. I can show you now. It's very, very easy. Let's say you have something in Excel. You just highlight it. Let's say that we have, this is Excel, right? What is this? Okay. This is, we have this Excel, right? And you have these numbers. Let's say you have 1, 2, 3, 4, 5. Sorry, mistake 5. Oh, sorry, 4. Let's say that this is the probability distribution. So I'm gonna make it so that Excel will allow us to draw it. I'm gonna make this bigger. Okay. Okay, make it bigger. I'm seeing, hold on, give me 1 minute. I'm seeing something I didn't put here. Okay, it's gone. All right, let's see. I'm seeing so many things here that I shouldn't be seeing. Give me 1 minute. Let me close all these things. They're blocking the space. All right. Now, can you see my screen here?
Yeah.
Okay, let's say that one to make Excel. Let us draw this scene. Okay, one. Okay, and 2, 3. For example, just give me an example. 4, and that this is the probability px 0.15, 0.25, 0.3, sorry, 3, okay, and 0.10. And that this is what you plug in Excel. So this is that you plug you drew this chart in Excel. Okay, I will have it in this form. See, this is the chart you draw in Excel. You can click here and press copy. Okay, I think it's from here. Say copy, and you can go to any Word document you are using. Any Word document you are using, you can go there and paste it. Okay, it's pasted. Then you can then type whatever you want to type. Okay, let's say that I've already typed something here before I pasted it. Paste it. It's there. You can keep typing. Go down here and keep on typing. Whatever I want to type. So paste it at the space provided for it in the homework. I mean, in the project. So it's possible to do that. Okay.
Got it.
Okay, thank you.
You're welcome. Now let's go to what we have today. Before Miss Dolly interrupted me. Miss Dolly.
Sir, I'm sorry.
You're in trouble.
I'm sorry, sir.
All right, let's see. So today we are looking at actually it is Miss Dolly and Miss Bista. They interrupted me. They are in trouble. Miss Bista, you there?
Yeah, I'm here. I'm laughing.
The two of you are in trouble now. Miss Bista, I replied your email. So you were able to figure it out at last, right?
Yeah, so Alex emailed me this morning and then we figured it out. So it's working now. So I was wondering, what am I supposed to do now? Like, am I able to still do it or?
It is the homework.
Right. I'm still able to do it, right?
What homework is it again?
I think it was 6, the confidential, whichever.
So what did they say happened to it? To your is it for your system?
It said the access code was not working for me. And
okay.
they gave me, I was like, what am I supposed to do? They were like, oh, you have to rebuy it. Or I was like, I have work to do for my class. I can't do that. And he's like, okay, we can give you this temporary one until I forgot how long it was for, but they gave me a new access code.
Oh, they gave you a temporary one?
Yeah.
Oh.
See.
Okay.
So it's working now.
That's good. Okay. All right, let's start. Now, test of hypothesis, regression, and correlation. Today and tomorrow we'll be working on test of hypothesis. And on Wednesday, we'll be working on regression and correlation. Okay, tests hypothesis. When you hear the word statistical hypothesis, it means a claim or conjecture about a population parameter. When we say a population parameter, I think I've explained this before. The population parameters include population parameters include things like the mean with the symbol mu. Okay, with the symbol mu. Here, mu. And things like standard deviation. So these are the things we have been dealing with since this class started. The numerical estimate of population characteristics. We call them parameters. See, these are population parameters, mean, standard deviation, and so on and so forth. That give us a numerical the description of the population characteristics. So the claim may be true or false, or true or false, but it has to be tested to see whether it's true or false. So usually in hypothesis testing, what the researcher do is to make the hypothesis, define the population, and specify the parameter that you have been studied. State the hypothesis that will be investigated, give the significance level. Remember the significance level we did when we were doing confidence interval. But for the confidence interval, we are using TwoTailed, significance level 2 tails. So that one is usually served. As a matter of fact, there is a confidence interval option of hypothesis testing, but we're not going to do that at this level. Then select the sample from the population, collect data, then perform the calculations that for the required statistical test. Then we reach conclusion. So we can test hypothesis for many different things. For instance, we might want to know whether a particular medication lowers blood pressure. Can it lower blood pressure? Okay. Does seatbelt reduce severity of injuries caused by accidents? Does the public or customer prefer a certain color in a new line of fashion? Does this method of teaching, is it better? The Zoom method, the remote method, and the teaching at the physical classroom, which of them is better in terms of students comprehending this concept that is being taught to them? Stuff like that, and so many other things. So that's what we examine hypothesis testing. Now, we have two types of hypothesis. One is the null hypothesis. The other one is alternative hypothesis. Null hypothesis is a statement that the value of the parameter equals some specified value. So we use some type of equality sign when we test null hypothesis. When we write null hypothesis. But basically, we use things like symbols like equals. Let me say equals. Okay. Less than or equal to. Okay, it's not right here. Comma. Greater than or equal to. These are some of the symbols we use when stating null hypothesis, because it involves some type of equality. Alternative hypothesis say the opposite of null hypothesis. So for this one, we use inequality symbol, like this not equal to, greater than or less than. Now, of course, because hypothesis testing is done by human beings, sometimes there's always room for error. we try to reduce that to that possibility of committing an error as much as we can. So, but we have this type of errors that usually occur. One is type 1 error, and the other one is type 2 error. Under type 1 error, we reject null hypothesis when it is true. But type 2 error occurs when we do not reject null hypothesis when it is false. So when we do not reject an incorrect null hypothesis, we have committed type 1, type 2 error. But if we reject a correct null hypothesis, we have committed type 1 error. Usually, we use this decision. We can use this decision matrix to determine which type of error is happening or is occurring in the test. So, like I said, the error usually occurs, but we try to reduce the chance of its occurrence as much as we can. Like if in a confidence interval, if we say we are 95% confidence, that means that our chance of committing an error is 5%. And when we say 99%, confidence level, our chance of committing the error, that means our chance of, rejecting a correct null hypothesis is only 1%. So how do we use this matrix to check or explain further what this error means? So I'm going to use this. So suppose we have this a legal case. This is that a defendant who is being accused of a crime is brought to court. So this will help us to understand what type 1 and type 2 errors are. So for example, now there are 4 possibilities here. The 4 possibilities are here that 1 is the defendant is not guilty and the defendant is convicted or not convicted. Okay, so the defendant is innocent, or is not guilty. The defendant is guilty. Defendant is guilty. Defendant is convicted. The defendant is acquitted. These are the 4 possibilities we have. So I want to choose to explain this type 1 type. So let's say that the HO is that the defendant is innocent. And this is the HO is true. HO true, defendant is innocent. Is innocent. Defendant is innocent. HO false, defendant is guilty. Okay. Now, reject
so
HO.
I have a question.
Yeah.
How do we know which category to put it in? Like, how do we know innocent goes in true and guilty goes in false?
I'm going to explain. That's what I'm trying to explain now.
I'm sorry. Go ahead.
Yeah. So reject HO means convict. Convict defendant. Then acquit. Do not convict. Do not convict. Okay, defendant. See, convict, defendant, do not convict. So now, if the remember the definition of type 1 error. This occurs if you reject null hypothesis when it is true. So when a null hypothesis is true, that means the defendant is innocent. But you know that when they bring the case to the court, now the prosecutor, or what they call the state attorney, will come and present their cases and evidence about it against the defendant. Then the defendant's lawyer will also present their own case to the jury. Now, it is now left to the jury to decide whether the defendant is guilty or not. Excuse me. Now, the decision of the jury is based on the weight of evidence against the defendant. If the defendant is guilty, but there's not enough evidence to convict the defendant, they will say that he's not guilty or she's not guilty. So everything depends on the weight of evidence against the defendant. So now, if the HO is true, that means that the defendant is innocent, but the jury convict them anyway, because there's not enough evidence to clear them. That means the jury have committed convict defendant. See? So if the defendant is innocent, that means HO is true, but the jury convicted the defendants, they have committed type 1 error. Now, if the defendant is guilty and the jury, convicted defendants, convict defendants, convict defendants, then they have made a correct decision. See, correct decision. But here, they committed type 1 error because they convicted it. Because you can see that from sometimes with the DNA that came out. Many it was discovered that many people were sent to jail in error because maybe during the time there was no DNA, and they made decision based on the witness testimony from witnesses, So those people were eventually released after the DNA cleared them. Now, if the defendant, if the HO is true, that means the defendant is innocent, and the jury did not convict them, then they have made a correct decision. Do not convict, acquit. Do not convict. Do not convict defendant. That means they made a correct decision. But the defendant, suppose the defendant is guilty, and they were released because there was not enough evidence to convict them. Convict, that means the jury have committed type 2 error by not rejecting a correct hypothesis. Okay, let me make it right. See, any question on this? Any question?
No, sir.
Go ahead. Oh, you say no, sir.
Yeah.
Okay, good. Now, now let us take a look at how to state hypothesis. Again, remember the null hypothesis. We use symbols like equals, not less than or equal to, and greater than or equal to. Then for the alternative, we use not equal to, greater than, or less than. Look at this. It says state null and alternative hypothesis for each conjecture. Excuse me. It says here, this one says a researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. See, will increase. Birth weight, average birth weight will increase. That's the key word there. he thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. So we have our HO, okay, and H1. Okay, we increase means greater than, and you can only use the symbol for greater than in the alternative hypothesis. So that means you write that first. HO mean, that means the mean we increase, okay, greater than, that means it will be bigger than the average birth weight of 8.6 pounds. Pounds. This is the claim right there. Now, the null hypothesis is just the opposite of alternative. So you're gonna be mean. Now the opposite of this is less than, but you cannot use less than here. You can only use less than or equal to in the null hypothesis. So we're gonna use this one, less than or equal to 8.6 pounds. 8.6 pounds. And that's a hypothesis right there, you have stated. Questions?
No.
Okay, good. Part B, number 2 says, an engineer claimed that the mean number of defects can be decreased in a manufacturing process for compact discs by using robots. See, can be decreased by using robots.
Can you highlight decrease?
Huh? Is it?
Could you highlight it? The decrease.
I just did, okay, with the highlighter, right? Can be decreased. That's what you said, right?
Yeah.
Yeah. Can be decreased in a manufacturing process for compact discs by using robots instead of one being for certain tasks. So the mean number of defects for this per 1,000 is 18. So now decrease means less than, am I right? Or wrong? Am I right or wrong?
You're right.
So, and because it is decreased, you can only use decreased in the alternative. You cannot use it in null. So that means have that mean, again, is, okay, this is decrease right here. Okay, I think I'm click on something. Okay, mean is less than 18. So this is our claim right here. Now, the opposite would be to write a mean is greater than this, because the opposite of less than is greater than. But you cannot use greater than symbol in the null. You can only use the greater than
or equal to, yeah.
Yeah. So you're gonna be mean greater than or equal to 18. See? Very easy to state hypothesis. Now, some people ask, will the claim always be in the alternative? No, it will not always be in the alternative, because sometimes it will be. It depends on how the question is worded. As a matter of fact, in some questions, what you're going to put here is the equal sign. So it depends on how it is worded. Go ahead.
You said some people asked if it was, say that again?
If the claim is always in the alternative hypothesis.
Oh, okay.
The answer is no, it is not always in the alternative hypothesis.
Okay.
Sometimes it can be in the null. And also in some examples, instead of putting less than or equal to, you're gonna be equal sign here. So it depends on how the equation is worded. Okay.
Right. Are you gonna do an example of where you use equal sign?
Of course. Well, here it says a psychologist feels that the playing soft music during a test will change the result of the test. the psychologist is not sure whether the grades will be higher or lower. So he was not sure whether it will be higher or lower. All he knows that it will change. In the past, the mean scores was 75. So he wasn't sure whether it will increase or decrease, but he knows it will change. So he said he feels that playing soft music with doing the test will change the result. We change the result. See, that's the keyword there. So HO, you have your HO and the H1. We change. That means it can decrease or increase. Am I right? So you're gonna be mean.
Change means what?
He said it will change. That means it doesn't know that it will increase or decrease. So
Right.
change means that it can increase or it can decrease. So in that case, it's gonna be mean not equal to 73. See? Mean not equal to 73. The opposite will be mean equal to 73. Mean average score equal to 73.
So which one would be the claim?
Well, the claim will be in the alternative here, claim.
So how do we know what the claim is?
Because here, see what I highlighted? That he will change the result. Yeah. Can be decreased. See?
Right. Right.
And see, at first it is confusing at first, but when we do many examples, you start getting it more.
Right. I got you.
Now, sometimes it might not be for mean. It might not be testing for mean. It might be testing for other things like a percent or proportion. Like here it says, at least 45% of senior citizens wear hearing aids. So in this case, we are not talking about mean. Like, unlike here, when we say that the psychology feels that playing soft music, we doing tests, we change the results, but at the mean scores, is something. That means we are talking about mean. Here, the same thing. The mean number is, so you see, we're talking about mean, but here we're talking about percent, proportion. In that case, no hypothesis is, we said at least we have our HO and H1. So he said at least 45% does not, at least means greater than or equal to. Am I right? If I say at least 45, mean that it can be 45 or more. So that one, you can use it here. It can only be used greater than or equal to in the null hypothesis. P, because this time around, it is no longer average, it is now a percent. So it's a proportion. P greater than or equal to 45%, which is the claim here. We'll say at least.
So why does it go in the HO and not the alternative?
It says at least. At least means greater than or equal to.
Oh, and greater and greater than or equal to always go in the HO part. It doesn't go in the alternative.
Exactly.
Right.
So that means this one P, the opposite will be less than that. So you have the opposite will be less than or equal to, but you cannot use the less than or equal to symbol in the H1. So that's why you're gonna use the less than that. See, now let's try an example for 5%. Look at this one here. So the average income, let's try one more, only one more, and with that you can do the rest as a practice. It says the average income of accountant is, select is means equal. And you can use equal symbol in the null. Have an alternative. So the average age of accountant is equal. So average income, that means mean equals 51,479. That is the claim.
And the alternative would be average does not equal.
Exactly. So mean is not equal. mean is not equal to 51,479. Okay. So, question before we move on to next stage. Any questions? So no
Pretty
question.
much in those type of questions, we gotta understand the question and what it's asking for, right?
Yes. Once you understand the question and what it's asking for, you'll be able to formulate the null and alternative hypothesis. Okay. Now, let us look at the terms used in hypothesis testing. First one is this level of significance. This simply means the same as the level of significance we did in confidence interval. It's called the probability of rejecting a null hypothesis when it is true. Another way of saying it is that the level of significance, which is the alpha, is the probability of committing type 1 error. I mean, so if you're using the confidence significance alpha of, let's say you're using an alpha level of 0.05, 0.05. Let's say you're using the alpha level of that. That means that your chance of committing the error is 5%. The chance of making that mistake is 5%. If you're using an alpha level of 0.01, your chance of committing type 1 error is only 1%. You know, that's what it means. Now, critical region is just another way we call a rejection region. And this critical region and critical value can be best illustrated with a diagram. Let's say that you have this chart where you have the hypothesis testing, you know, like we do in normal distribution. Okay. Okay, I'm gonna move this down a little bit. So critical region, and another word for it is the rejection region or the acceptance rejection region, basically. So you put the x-axis, and then you have your okay with this okay. All right. Okay. Now you put your of course the center line, the mean. This is your mean here. Okay, this is your mean. All right, 0. And these are the where we are. And this is where we are. Okay. You can remember the critical value from your okay. From the what we did on confidence interval. This is Z, is the critical value. And this is also Z. Now, these are the areas that if we call it a critical region. Okay, we have it here. All right. You reject, if you fall it here, you reject. Okay. Yeah, they say that a picture speaks 1,000 words. Okay. So you see, if you see this shaded place, any answer that falls in that place, you reject. Okay. And then, okay. Now, the unshaded portion is called the acceptance region. Acceptance region, which is used for this unshaded portion. This side, this place, acceptance. But anything that falls on this above that, then rejection or critical region. Critical region. So anything that fall in that shaded space is here, starting from here. It started from here. See, excuse me, here. Anything that falls here, reject. So this place, this particular place where it starts, is called a critical value. Right? Critical value. Okay. Value. Okay. You now from here, see, this is right here, fall right here. So let's say that this is the, let's say that Z, let's see, I'm gonna make it, okay, good. Let's say that this Z is equal to 2.3. That means 2.2 is the critical value. From anything from there, actually negative because it's on left side. Anything from here all the way down, you reject. Now, the same thing with here, we have rejection region, rejection or critical region. See? And that is right here, start from here. Okay. Let me see. Okay. So anything that, if your answer falls here, just so, and this is the critical region, critical value, where it starts. In this case, let's say that it is 2.3, 2.3 or 2.4. It doesn't matter what answer is. So if your answer falls here, but if your answer is say, let's say that your answer is let's say the answer is something like 2.18. In that case, it falls inside this acceptance region. In that case, you do not reject. Question?
This graph is a little hard to understand, but I guess, yeah. Do you have a math portion?
Yeah, we do the math portion. If you understand this basics, when we start doing the math portion, it will become easier for you to understand. Yeah?
You said 2.8, you accept?
Yeah, because 2.8 is, for see, this one is, this is 2.3. 2.8 is less than 2.3. That means it falls inside this space here.
Okay.
Now, when we're talking about that, we're talking about the absolute values of this. Even here is the absolute value of negative. For your algebra class, you know that the absolute value of negative 2.3 is also 2.3. So, and 2.8 in each case fall within this space, because 2.8 should be around a little bit below 2.3, maybe about 2.8 around here. See, not in the, you did not fall in the rejection region. In that case, you do not reject. So two-tailed test and one-tailed test. So that's the kind of test we do when we do hypothesis testing. There was called two-tailed tests and one-tailed test. Two-tailed tests use the fastest way to understand it is to use a chart. So I'm going to use charts like here. Let's say this is a example that we have. Okay. All right. Okay. And that our x-axis is right here. Okay, and this is inside here, the zero part. And we're looking at this only one side of it. Let's say less than 2 points, negative 2 points, 2.1 point something. It doesn't matter as long as it's on the negative, it's on the left side. In that case, it's a left tail. Okay. So this is a type of one-tailed test. Okay, this is because it's fall in the left tail. Okay, it fall in the left side. Okay, the left tail. Okay, you know. So we call it left tail test. Left tail test. Because it's for our interest is in what's in a rejection region that falls in the left tail. See, this is the right tail here. This is left tail. Now, for right tail test, you might have something like this. Okay. Oh, excuse me, sorry. A mistake. So you might have something like this. We have it in this form, the same thing. Okay. Okay. All right. And have your x-axis from here. And of course, the mean at the center of 0. Now, if I'm looking at the critical value, that's if a test falls on the right side, like here, where the shaded portion is on the right side, we call it a right tail test. Okay, right tail test. Okay. All right. One more, and I've done that. Called the right tailed test. So it is called the right tailed test because it falls, the critical region is on the right side. And of course, we're interested in a value, a test value that falls on the right side, right tailed test. So you can see that sometimes it might fall on the both sides. It might be either side, like the one about the psychologist, can be on the left side or right side. In that case, we call it two-tailed test. Okay. I have it. Okay, we start from here. Okay. Okay. All right. And then we have our x-axis here. And put the center line. So that means it can be in the right side, so the left side, or in the right side. Okay. So you have this, it might be here. Okay. Here. Okay. Now you can see it right here. All right. Or it can be on the left side, you know, on the left side. So because it's a two side, it can be on either side. We call it a two-tailed test. Okay, this is a two-tailed test. Now this is how we state hypothesis for two-tailed test. It can be said that HO and H1. You can say that HO can be mean, okay, mean equals to K. K can be any number, at all. Then alternative will be mean not equal to K, where K can be any number at all. So whenever you see a hypothesis in this form, where K can be any number, it is called two-tailed test. One is equal and the other one is not equal to. But for left-tailed test, the hypothesis can be stated in this form. You can have it in this form, HO, okay, and H1, HO can be mean greater than or equal to K, where K can be any number. H1 will be the mean or the proportion, whatever you're testing, is less than K. So less than all in the alternative always goes to the, for left-tailed test. For right-tailed test, we can state the hypothesis this way. We can have it as mean, okay, mean, okay, less than or equal to K. Then that will be our HO, okay, and H1 might be H1 might be mean, okay, greater than K. As you can see, the greater than always tell you that it's on the right side. So let's basically, so we look at the hypothesis we stated before. You can see that this one is the right-tailed test because it's using greater than symbol. This one is a left-tailed test. This is a two-tailed test. This is a left-tailed test, two-tailed test, and so on and so forth. Questions? Any question, class?
No.
All right. Now it's time to apply this theory. I believe the theory is practice. And apply the principle you just did in solving, in doing a test of hypothesis. There are two types. We have the types of hypothesis we test. There are two types. We have the traditional method we use. Traditional method. And then we have p-value method. Now we do traditional method today. Tomorrow we do p-value method and the other methods. Under the traditional methods, let's start with the z-test for the mean. The principle process we follow is this: state the hypothesis and identify the claim. Find the critical values from the table of normal distribution, let's say Z table or any appropriate table we are using. Then compute the test value. Then make decision to reject or not to reject the null hypothesis. Then again, you summarize your results. Now, how do you decide whether to reject or not reject? The criteria is this: you reject the null hypothesis if and only if the calculated value is greater than the critical value. The critical value you'll find from the table of normal distribution. So if your answer is bigger than the critical value, you reject null hypothesis. If it is not, you do not reject null hypothesis. So for us, for the test statistics, we use this formula here: Z equals X bar, X bar sample mean minus the population mean, divided by standard deviation over the square root of n. So, and we're going to be using that table I told you about, statistical table. So let me open the statistical table. Let me open it so that we can show you, you can use it. Statistical table. I have it, remember I have this table in the files section in Canvas. So, so we'll be using it for this. Test one, I'm opening it now. Let's open it and then, yeah, we'll be using this portion of it. Can you see the table? Can you all see the table?
No.
Okay.
It didn't come up.
Okay, I'm gonna open it again. Let's see. Okay, I'm gonna open it again. If you don't have it, you can get it from your Canvas under files. Can you see it now?
Yes.
Let me make it bigger. Again, it is in Canvas. I say it's been there since we started doing binomial distribution. Now, this is the table we're talking about here. So now this is where you get a critical value. Let's try an example of testing hypothesis. And tomorrow, say, look at this first question here. It says that I'm gonna close this side. Okay, it said a researcher reports that the average annual salary of assistant professors in the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,000. At alpha 0.05, that means significant level, test the claim that assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. So see that they earned more than, excuse me, that they earned more than. Who can tell us what symbol to use here on this one?
Greater.
Exactly. So the first thing is let me move this to a page where we can have more room. Okay. Solution. Okay. Solution. So let's say the hypothesis first of all, HO and H1. Okay, the claim say that test the claim that the assistant professors earn more than, so more than is greater than, so you can only use more than in the alternative. So that means that we put it here, more than, to write that one first. Okay, mean is greater than 42,000 dollars. The claim here. Okay, and here we have that's the opposite of that. Mean is less than 42,000, but you cannot use less than here. So you're gonna use the greater than or less than or equal to symbol. Less than or equal to 42,000. 42,000. Now, a sample of 30 assistant professors, right? And start. So is 43,000. Now, somebody will say, okay, the sample of this, we have 42,000. So I mean, 43,000 is bigger than 42,000. So why are we running the test? Well, remember that 30 is only for 30 assistant professors, only a small sample. And we don't know whether this will be the same for the entire population of assistant professors in America. So because of that, we still need the test to do the test. Okay, especially given that we have the population standard deviation. So to do the test, let us find the critical value first. Alpha is what? What's our alpha here? Can tell us? What's our alpha?
0.05.
0.05. So if we are, you mean that if we are going to commit type 1 error, our chance of committing that error is only 5%. So now we can get a critical value. Now, this is also a right-tailed test because it is greater than, so it is a right-tailed test. You mean that if you draw the chart might look like this. it will be in this form. Okay. All right. Okay. Okay. All right. So it's gonna be like this. I will have our center line mean for the standard. Okay, mean is 0. You know, I'm gonna move this up a little bit so that it will not. Okay, I'll move this one up a bit too. All right, I'll move this. Just a little bit. Okay, now, so that the critical value we are looking for should be on here. See? And then, you know, we can shade up. So because it is greater than, that's why it is like that on the right there, because it's say greater than. Okay, so be on the right there. Okay. All right. Okay. Okay. The computer sometimes acts crazy. And then last one, the critical value is somewhere here. So let's find the critical value. So, and I remember I told you when we are doing normal distribution that when it is on the right there, you have your critical value Z, critical value is on the right there. It means ZC equal, I mean Z critical. Okay, will be whenever it's on the right there here, you look for the probability value. They give you as 0.05, subtract it from 0.5. So 0.5 is minus, the probability they give you is 0.05. Plus 5% is 0.05. Okay. Of course, we have to make it for the smart place because of the table of normal distribution. So that gives us from the calculator, this most we have at 0.5, 0.05, sorry, 0.5 minus 0.05, give a 0.4500. So we have 0.4500, 0.4500, which when you look at the table of normal distribution, will give you 0.450. You choose a value that is closest to this. So you go to the table of normal distribution. 0.45 should be, see, we have two of them very close to it. Remember, we have it last time. We have 0.4495, which is 5 points away, and 0.4505, which is also 5 points away. I remember that I told you that if it's in this form, choose the bigger one, which is this one, and follow it to the left, 1.6, and it goes up 1.65. So the critical value is 1.65, 1.65. So now we are ready to run the test. So you state the hypothesis, find the alpha value, find a critical value. You are ready to write. So that means the critical value will be somewhere here, 1.65, 1.65. See? Now we are ready to run the test. Again, remember the test statistics is this. We use this formula here for the test statistics. We have it here as our test statistic. So sample mean, our sample mean X bar, we can get from the other workbook, since this workbook doesn't have a character for that. Let me write this down first, the sample mean down, and then population mean. write it down before I put them in. So the sample mean, according to the question, the sample mean is, for the sample of 30 is 43,260. And the population mean, see that the average for the entire population is 42,000. And the sample size N is 30 assistant professors. And the standard deviation is, you can see right, 5,230. Okay. Now you can plug all this in. So let's write them down first of all. The sample mean from the other workbook. I mean, where we can get our X bar, excuse me. Our X bar is, so sample mean, equation, you can see the X bar right here. I think it's somewhere here. Okay, my computer is slow today. Sample mean X bar equals 43,260. Okay, now I can copy this. And then, okay, put it in our main workbook. Sample mean is, say, 43,260. Okay. Then population mean mu, we can get that one from here. Mu is 42,000. The standard deviation N is, we'll have it here as 5,230. And sample size N equals, for the 30 assistant professor that is sampled, is 30 and N is 30. So we plugged all this inside this formula to get our Z value. Once we get our Z value, we compare it with the critical value. If it is bigger, we reject no hypothesis. If it is not bigger, we do not reject. So we have it here. So plugging it in means that that is what you mean by running the test. You have it in this form. Okay. So we have our Z equals sample mean of 43,260 minus population mean of 42,000 divided by the standard deviation over the square root of N. Standard deviation of 52,000, so 5,230 over square root of N, which is square root of 30. Okay, 30. So now this takes us to the calculator. We have it here in our calculator that okay. Right, where is the calculator? Right here. Okay. We have the sample mean. Okay. 43,260 minus population mean of 42,000 divided by standard deviation of 5,230 over divided by the square root of N. N is 30. Okay. Right. So, well, I didn't put the square root of N. So the square root of N, I'm going to put square root of that, of 30. Square root of 30. Okay. You can see the answer becomes 1.31956 and so on. So we just write that 1.32. 1.32. Yeah. Right there. 1.32. we have 1.32. So I'm going to copy all of this and paste it in our main workbook, which is right here. Okay, 1.32. We have run the test. What is the, why the test is, okay, I think I'm going to make some correction there. The character just slipped through the formatting space. Okay. 1.32, 1.32. Okay, that's better now. So I'm going to again go back and paste it here. See? Now we have run the test. This is our result. So let me move this. Okay. Now let's make our, remember the question says that is there at alpha 0.05, test the claim that the assistant professors earned more than 42,000 a year in 1997. So our critical value, let's make our decision. Decision. A critical value. Critical value. ZC is 1.65. 1.65. Calculated value Z equals 1.32. So critical value ZC is 1.65. Calculated value is 1.32. Remember, we stated our hypothesis. We got our critical value. We run the tests to get 1.32. Remember that the criteria for making our decision. Reject null hypothesis if the calculated value exceeds the critical value. Otherwise, do not reject. So now, if you compare the two, the critical value is 1.65 and the calculated value is 1.32. Because the calculated value is less than the critical value, we do not reject. Do not reject. Do not reject the null hypothesis because the calculated value of 1.32 is less than the critical value of 1.65. If the answer is bigger than that, we reject null hypothesis, but it's not. So our conclusion here is this. Now, remember the claim was that they make more than 42,000. Now, we did not reject this, the null hypothesis. Null hypothesis said that they make less than that, right? But the alternative said that which is where our claim lies, so that they make more than that. Since we did not reject null hypothesis, that means we are not taking the alternative hypothesis. So that means we can say that there is insufficient evidence. There is insufficient, or there is not enough evidence to support the claim. That, see, again, since we are not rejecting the null hypothesis, that means that the claim here is not correct. Because we are not rejecting this. That means we are not taking this one. So there is insufficient evidence to support the claim that assistant professors earned more than 42,000 a year. And more than that's assistant professors earn more than 42,000 a year in 2000. That's it. That's no hypothesis. Any question for me? Any question?
Yeah.
No, no questions.
All right. Tomorrow we begin. I will do an example for p-value method, and then we do an example for when the sample size is small, and then of course we can then go to next following day we go to correlation and regression. Now let me take your attendance and then we can leave for today. I got the John. Today is 9th. Yeah, I got the John.
Yes.
Vanessa is here.
Yes. Have a good evening.
Got Vista. Okay, Rita Ford. You sure you're here, Miss Rita? Rita Ford, are you here?
I was trying to unmute myself. I'm here.
By calling Science and Kirk. When you need a lawyer,
Elsie.
you have a lawyer.
Paul is here.
I'm here.
The lawyers at Science and Kirk can get
Bobby.
right away. When you're
Walker.
Say my
Tiffany
name
Walker.
yet?
I'm here.
Barbie's here.
I got Bobby.
Professor?
Yes, ma'am. Docket.
Say my name yet?
Takia Docket. I got Takia Docket. Is that you?
Here. Good night.
Good night. So who else I have here? Walker. I have Walker. Kent. Kent, you there? Okay. All right. I think I got one of what I have. 1, 2, 3.
You have Beasta, right?
Yep, I got you.
Thank you.
Welcome. So I see you guys tomorrow.
See you. So, question about my test. I can do it, right?
Yeah, is it still open?
I'm not sure because it's over the due date. That's why I was gonna ask.
Yeah, let's see. What test is that? Test
Too.
Huh?
And the homework too.
F2 and homework 2, right?
Homework 6, sorry.
They're all past due, right? I think.
Yeah, it was supposed to be due yesterday.
Let me see if I can help you here. But this time around, you have to finish them. No more second chances, okay?
Okay, I promise.
Be a good girl now. Be a good girl now and finish them.
You know how many attempts we have?
Well, for homework is unlimited attempt until it's due.
And then what about the test?
Test is only 2 times or 3 times.
Okay.
So I'm just gonna update the due date.
Thank you so much.
And then do it. Okay.
You gave us a lot of work for this week. Oh my God, the project and
I did not. You guys should give me some credit. I spaced the work for you so that you don't get overwhelmed.
And so the final exam, you know when that's gonna be uploaded to Canvas?
What? No thanks for what I just said.
The final exam.
Oh, you're talking about the final exam?
Yeah, you know when that's gonna be uploaded?
It's there already. I'm just gonna make it available.
Okay.
I'm thinking of making it. You take it in Canvas.
Okay.
I have to upload it, make it available on the day it is supposed to be taken, which is on Monday. So, but I'm going to make it available Sunday night, midnight on Sunday, so that you have all day Monday to take it.
Okay, thank you. You be uploading stuff at like Sunday, like 3 a.m., 4 a.m. I'll be up, right? And I look at my phone, it's like, oh, Math 107 updated.
I work hard for you guys. I work very hard to make you guys, Happy.
Thank you. Yes.
Welcome. So I'm gonna move the date to okay, let me be nice. Be sure to complete it on the last day, which is the 15th. Okay.
Thank you so much, Professor.
Yeah, that's what that
I
for test.
truly appreciate it.
Yeah, you're welcome. To make it our homework 6. Say homework 6, right?
Yes.
Homework 6 close. So I'm gonna put it. Test 2 is not homework 6. Homework 6. I'm gonna make it that same day, 2:15. No more excuses, Miss Beast.
I got you. I'll be done. Thank you.
All right. I've stayed too much with you today. I have to leave you now. Okay.
Okay, you guys have a great day.
You have an evening.
All right,